In this podcast episode, I'll go through some of the more foundational theories for the natural sciences called empiricism and also Popper's critical rationalism. I think they go together somehow. That's why I've included it in one podcast episode. So first, empiricism is generally a movement in theory of science, putting a lot of emphasis on experience of the outer world. As they were reluctant to speculate too much about the inner world, they wanted the concepts used in theories to rest on the most simple, intuitively correct concepts as the basis of the theory. This way, they did not have to speculate too much about and establish theories about the inner dimensions of human experience and knowing. This seems aligned with Occam's insistence on simplicity, and the minimum amount of assumptions makes a theory superior if it rests on a clear and simple amount of first principles for the explanation. Logical positivism is a branch within empiricism claiming explicitly that, and I'm quoting, the meaning of a sentence consists of its methods of verification. So true objective knowledge needs to be rooted in specific experience of the outer world and not based on some already existing ideas, as Plato would claim. So here a lot of emphasis was on rooting knowledge in careful explanations of the circumstances under which the experience or verification was created, so that somebody else easily would be able to recreate the experience independently of the first person experiencing this. Something is objectively true if it is described well enough for anybody doing the same can experience the same. I think this is the most important and useful definition of the word objective in science, where objective knowledge is grounded in correct use of theory and method rather than whether the science in focus bases itself on collecting data from the inner dimension of human experience or about the physical outer world. More about that later. Here I just want to mention that it is in the spirit of empiricism that scientific articles always are extremely detailed in the description of the whole technical setup of a research project and how the data was collected. It needs to be described specifically enough for somebody else to repeat the project and end at the same conclusions. Only then it is seen as objectively true, because no possible personal bias can have been affecting the outcome, and anybody doing the same would end with the same conclusions. Here there is an emphasis on the input into the project for anybody to repeat the project if they want. So, to conclude, a sentence without a specific method of verification has no meaning. I can't help to think about the roasting defect curriculum of the old SCAA roasting education system, where I always thought that the circumstances for creating the individual defects were anecdotal rather than specific, and therefore I never thought that they were good theories because I would not really know how to set up the test to prove or disprove them. I tried to create a more specific, systematic and simple approach in our first roast profile studies, leading to my first scientific publication on coffee roasting. And I would say that my simpler and more specific approach is more useful, at least as a scientific theory. And I'm not saying that it's proven or anything yet, but I'm just saying the approach to even setting up the explanation, explaining the different defects is more specific. So in order to get to a deeper level with this, I created a sample space of 6 different roast profiles as a hypothesis to be tested. And I have been happy with the outcome of 5 of them, as I feel that the underdeveloped the definition of the underdeveloped roast profile did not come out very useful for the community. I think that the area of roasting defect is an area that might be developed further in the coming years, where we will have described specific circumstances, but also meanings for example, underdeveloped that are used in many different ways. And just to mention something interesting about the diversity of how this is used very differently in the community. I just remember a session I did with Nolan Dutton at a Roasters Guild camp, where we asked the audience for definitions of roasting defects and ended up with more than 6 different definitions for baked. I think that specific, simple, and based on root causes should be the principle with which we search for new theories. And following Occam, a good theory would be grounded in the root causes of the system and be expressed in, for example, flame settings, time and temperature observations of physical and chemical founded events, rather than speculative, elaborate, mathematical derived calculations in Roastlogger software. I love Roastlogger software, and it's highly needed for many reasons, but sometimes people care more about discussing the shape of curves and fluffy calculations online than actually the coffee coming out of the roaster. That was empiricism, and now I go to critical rationalism. And this is Karl Popper's approach to really zooming in on what is a good theory and what is a bad scientific theory. So, where Plato wanted to distinguish opinion from knowledge, Karl Popper wanted to distinguish science from what he called pseudoscience. And he developed an approach where he focused on falsification of a theory rather than verification of a theory. Because verification was the focus of empiricists that I just talked about, but he felt it wasn't enough to kind of distinguish between a good and a bad theory. It wasn't that he disagreed with the empiricists in the importance of experience as the foundation of scientific observation, but just like Plato, he did not think that observation is enough if you don't apply the right and critical method. So Karl Popper says, a hypothesis is scientific if and only if it has the potential to be refuted by some possible observation. So where empiricism is very specific about the input of a theory, Karl Popper was very focused on the output of a theory and also the hypothesis in the theory behind the predicted outcome. Karl Popper was, like Plato, annoyed that some theories were presented as if it was qualified knowledge without being it. Where Plato had mathematics and dialectics as methodology to refine theories to qualified knowledge, Popper focused on looking on the strictness with which the theory related to the predicted outcome of the theory, as he really did not like theories that verified itself again and again, because it was not specific enough in the described outcomes to ever be refuted by any possible observation at all. He was particularly critical towards some branches of psychology, Freud and Adler, and some social sciences such as Marxism. It is not enough to prove the theory or verify it. A good theory is specific enough with input, hypothesis, and output so that at least theoretically you can imagine, or hypothetically you can imagine situations where your theory would turn out to be false. Another place a theory can hide without being refuted is if the outcome, even if it exists or not, is so small that it can't be perceived by anybody anyway, in which case nobody would find an outcome where the theory would be falsified or refuted. A simple thought example would be in place to show you how this works. Let's look at the theory behind gravity. Gravity pulls objects towards the center of the Earth, or any other big object in the universe. Let's see if we can verify it. I will hold a stone in my hand with my palm facing down, and hold the stone firmly enough with my fingers to make sure it does not fall out of my hand. If I open my hand, the theory of gravity would predict that the stone would fall to the ground. I could test this, and I hope everybody agrees without me having to demonstrate it, that this would indeed happen. The stone would fall to the ground. So far, we have verified the theory. That's great. The empiricists might be happy, but Popper, he wouldn't. He would ask a bit more critically to the theory. In order to test if it is a good theory, you would have to come up with a situation in which case the theory would be disproven if a certain observation is made. If the stone stays in mid-air after I let go with my hand, the theory of gravity would be falsified, which is good for the theory, because if it's specific enough when it comes to the predicted outcome, so that at least in theory some outcomes can be ruled out by the theory, then it's a good theory. A good theory takes chances when it comes to possible outcomes. If it is not narrow and specific in predicting some outcomes and ruling out others, it does not really say anything about anything at all, as all outcomes would be verifying the theory, and no possible outcome would ever lead to questioning the theory, as no outcome is ruled out by the theory. If a theory never predicts something specific and also never rules out other specific outcomes, nobody would ever be able to catch the theory in being wrong. The focus on different aspects of the shape of the rate of rise curve of a roast process, I suspect, falls within this category. In the SCA roasting intermediate and professional classes, students are asked to discriminate and identify different samples, and among these are samples with very different development times. And of course, thinking about the everything else equal principle, these roasts has to have the exact same color. Otherwise, the color would be the reason that they taste different. So here you have 3 different samples, all roasted to Acton 75, with respectively 1.5, 3, and 6 minute development times. These are huge differences compared to many of the differences talked about in the general coffee community. But having had close to 1,000 students through the SCA roasting exams, I must just conclude that most students fail to clearly differentiate these otherwise big differences in development time between roasts. Even though most of the attendees on an intermediate level and almost all of the attendees on a professional course have massive practical experience with roasting and cupping, and only extremely rarely does anybody get all of these correct when they are asked to differentiate and identify the different roasting extremes in development time. Most would get only some right, and surprisingly many would really struggle. This observation was the reason that I was not even sure we would get any good data at all when we started the sensory evaluation of roast profile modulation, which luckily ended up being really good data, which we published in the article with the title, "The Effect of Roast Development Time Modulations on the Sensory Profile and Chemical Composition of the Coffee Brew." This research is available for free on Beverages' homepage. You can get the PDF of the full research for free because it's an open access article. So please go to Beverages and search for Morten Münchow. Then 3 articles are available there for download for free. 2 are about coffee roasting, and 1 is about food pairing, another project we did. So my fear about the differences perceived between roasts with different development time was that all my personal observation over the years are more likely my good stories than really systematic differences in flavor when tasted by a blinded panel tasting the samples in triplicates and randomized order. So I had a lot of theories about the flavor modulation based on development time. And I really feared that these differences were so small that a panel wouldn't be able to pick it up. And my point is that if experienced coffee roasters who attend the SCA Roasting Professional course struggle to taste the difference between 1.5, 3, and 6 minutes, I doubt that anybody could tell the difference of a smooth or slightly bumpy rate of rise curve. It's simply too small differences to be relevant. If coffee professionals struggle to taste this, think about how most consumers would struggle. The value in a theory is in the output, which is the sensory difference. And if they are small, they don't have a lot of value and could survive as claims in the community for a long time without even being refuted, because nobody dares to discuss with a very elaborate theory, even though it is only elaborate in the input parameters and calculations and not in the output parameters, which have to be the sensory properties to be relevant for the coffee community. Because we really struggle for people to take sensory science seriously and also to accept how easy it is for everybody, and particularly trainers who makes a living coming up with good explanations, to talk about themselves up in a corner and convince themselves and hundreds of students that they have found a really important small aspect that makes a huge difference. I have for 10 years or so told my students that there's a reverse U-shaped relationship between development time and body. My claim was that short development time and long development times has low body, but that there was in between a maximum where you would have higher body. Having supervised a master's thesis project on this explicit subject, where we tested this hypothesis and also Rob Hoose's hypothesis about relation between body and time to first crack, I'm now convinced that I might not be right, because our panel did not find any modulation of body while finding a lot of other strong modulations of flavor when doing these experiments in a strictly scientific setup. With Rob Hoose, we tested his claims on how body is increased with longer time to first crack, and also here our panel failed to find anything. But here it is interesting. I've tasted his modulation twice, once here in Copenhagen and once at UC Davis, and I felt that I could pick up what he meant. So either I'm biased by being convinced while tasting, or we failed to calibrate the panel for exactly what we picked up as body, or the third possibility is that that difference doesn't exist. If we do not calibrate the panel correctly for picking up exactly what we are looking for, they might not find it, even if it's there. So I'm a bit stuck between not finding anything, but still personally believe that Rob is onto something, but so far we've not been able to find it with a panel. We did find extended aftertaste and higher bitterness for extended time to first crack, which might capture something in the flavor modulation that Rob and I would call body. I think this is a good example of how science is not too strict and does not have to be and it doesn't have to be that strict. You can still have a personal hypothesis, and if you don't find it, you learned about panel calibration and whether you have done it correctly, but you also learn that the differences you're looking for is really small, because if it was big, it would have been found by the panel. I think this leaves the theory of increased body for extended time for first crack in a situation where it's not necessarily rejected, as we can't rule out that we in the future studies will be able to zoom into what we believe is there. The good aspect of this theory, though, is that it is rooted in the first causes of the roasting process, which is time and temperature itself, and it is specific when it comes to what it tries to predict: elevated body for longer time to first crack. That's specific, and that is a good theory, because it's predicting something and ruling out something else. So as a theory, it is correctly formulated. Next step is to test empirically what it predicts or not. Also notice here that there has been a dynamic activity between hypothesis testing and refinement of hypothesis, so perhaps the last word is not said regarding this subject. But after the testing, I think it's fair to say that if there if there is something, it is an extremely small difference, difficult to pick up by anybody not skilled in tasting, and therefore, if it exists, it would be only relevant to a few and very discernible customer segment around the world, which is fair enough because they exist, and you have to, of course, optimize your products to those types of segments as well. Talking about small differences and different control parameters, it is important to reflect this into basic chemical concepts to understand and evaluate the expected effect on different parameters. Again, talking about the focus on small bumps on the rate of rise curve, I feel it is a bit far out from a chemical point of view. If we should look at the situation from a chemical perspective, we would ask, what are the temperature differences we are looking at? And it turns out that these bumps might only be in a magnitude of a few degrees, such as, 2 to 3 degrees. And if small causes have small effects, it's difficult to even prove. But even worse, it is difficult to refute because nothing about the evaluation of the theory is clear anyway, as a clear sensory consequence would be needed for the theory to predict anything useful and also be specific enough to be refuted. Another problem with this theory is that it connects technical aspects of the roast directly to sensory preferences without really being specific in the sensory descriptive part of it. It doesn't really explain specifically what happens to the flavor. And if it doesn't, it's difficult to really map it to different types of preferences. What is it exactly that the theory predicts when it comes to the exact described flavor outcome of different shapes or behavior of the small variations in rate of rise? You need to describe what happens from a sensory descriptive, which is not preference point of view, and how it is related to technical aspects of the roast. After mapping this out, you can later find correlation between doing it in one way or another way and find people don't agree on which is better. Some people would prefer one and some people would prefer another, and you need to have a theory that is big enough to kind of leave that question open so that you can pursue preferences after mapping out the technical modulation of these changing these input parameters. If you just say something very technical about the roasting conditions and what should be done, and then jump straight to whether this is good or bad, you fail to really describe what's going on before judging one thing bad and another thing good. Mixing technicalities and preferences without describing the flavor first makes it a weak theory because you can't describe why somebody would find it bad. Technicalities of the roast should be linked to descriptive data in the first step. Preferences has to be taken completely out when doing this work because that clouds the purpose of the theory. Once you are clear about how technicalities and descriptive flavors are related, then you can start experimenting with different types of products and see that there are a lot of very different opinions from different types of coffee drinkers, and going straight from technicalities to preferences, you would miss out on this complexity and you would get a very one-dimensional model to work from in your product development, let alone a very one-dimensional model for the global coffee community to navigate product development. I'm not saying that there's not anything to be found when looking at rate of rise around first crack, and there might be some interesting events around the crack, such as sudden volume increment for the accumulated steam and gas leading to first crack, but we would still have to have a pretty specific theory and why such a small event could have a major chemical impact and consequently a big sensory effect. As mentioned in the beginning, it is very rare that a small cause has a big effect. And even if it has, we should first describe how intensities of different flavors are modulated before labeling some technical configurations of the shape of the curve, good or bad from a sensory perspective. Sticking to first principles such as flame settings during the roast, time to first crack and after crack, and the color of the coffee, which is a sign of the total accumulated energy in the beans after roasting, seems like a well-grounded theory because it's clear and well described how temperatures and time has a major effect on food substances. That's very well known in food chemistry, and that's related to a field in chemistry called kinetics. That's the speed of different types of chemical reactions. Formation and breakdown of molecules happens because of thermal energy. Thermal energy is molecular vibration of a material which is initiated by the flame in a roaster, and therefore the flame is the first principle in the system. These vibrating molecules will meet by chance, and as they vibrate quicker at higher temperatures, more meetings are happening per time unit, so per second. And at lower temperatures, with slower vibration, we can just wait for a longer time for the same amount of molecules to meet as if when the temperatures was higher at a shorter time. All this happens during good old seconds and degrees of Celsius or Kelvin or Fahrenheit, depending on where you are. In a small experiment, we measured the effect of time in itself in the roasting process by creating a series of isothermal, which is a fancy scientific word for keeping the temperature the same. And we did these roast in the Ikawa, and we measured a steady increment in color of the beans, taking them from action 120, which is extremely light, to 65, which is very dark. And this was just by waiting for them at the same temperature to become darker and darker. The temperature was the same throughout the roast after first crack. And as the development time increased from 30 seconds to 4 minutes, we kept it at 210 degrees after first crack. In the beginning of the roast, there was approximately a 10 action drop per 30 seconds, and in the end of the roast, only a 4 action drop per 30 seconds. It seems that time in itself has a big enough effect to expect a sensory difference, at least when we talk minutes of different development times. When it's less than a minute of development time, the differences are so small that few, even coffee professionals, can pick it up. Another type of vagueness of a theory that would fall for Popper's criticism is the theory if the theory is vague because of the nature of the output parameters of the theory. Here the types of sensory descriptors could play an important role, looking at the type of descriptors. Just to explain thoroughly, descriptors being specific enough to be included in a good theory could be starting on solid ground with the basic tastes, level of acidity or level of bitterness, or other very specific descriptors with simple physical/chemical objects as references, such as hazelnut, orange, or tomato, as opposed to more fluffy and unprecise and abstract descriptors such as balanced, clean, structured, or complex, as they are too vague and opinion-driven. The only place for such opinion-driven descriptors could be if the theory is trying to map out the opinions of a specific consumer segment, and not in a descriptive sensory analysis. Another theory that would fall for Popper's falsification in extension of the mentioned sensory descriptors above would again be the use of development time ratio and any optimum related to this, because it fails to predict anything specific. What is it specifically that it tries to predict, so that even in theory you can imagine an example where it could potentially be refuted by some specific observation? I have only ever seen balance to be associated with development time ratio, and balance is so opinion driven that it is to be considered a really unspecific claim that nobody would really ever falsify it. If it's not specific, it can't predict anything and therefore not be falsified, and then Popper would call it a bad theory. I would have to agree. Let alone that if you can't predict anything specific, it can't help you to design a preferred outcome for anybody. A theory without a prediction of a specific outcome is difficult to use for anything, as it does not predict something specific. But Popper's biggest problem is that since it does not predict anything specific, and therefore also don't rule out any particular outcome, it will survive as a good story for a long time, because it can't really be caught being wrong, because no outcome would ever expose the theory of being wrong if it does not exclude any even hypothetical outcomes.